to bundle multiple physical link into single
logical channel.
Logical link. Right. Now, as I told you, we have three methods for EtherChannel. Right. First one is static method. Static. Second one is dynamic. We can use protocol like PAGP. And third protocol is LACP. Okay. So first of all, we will see the static configuration, guys. How we are going to, bundle multiple physical link into single logical link with the help of static method, manual configuration. Okay. So see here, I have same topology in EVNG. If I will access these switches on this switch, so a spanning tree. Both port of this switch 0/0 and 0/1 are in forwarding state, and DP, because this switch is root bridge. But on switch number 2, one link is block. So a spanning tree. 0/1 is alternate port, right? Status is blocking. That means if PC1 want to communicate with PC2, switch 1 will forward traffic from E0/0 only. From E0/0 only, right? Lower link is inutilize. So if you want to use both link, what you need to do here, either you can disable a spanning tree protocol, right? But again, if you will disable a spanning tree protocol, what will happen? Loop will form there, right? So another method is EtherChannel. With the help of EtherChannel, how we can bundle these two ports. See on switch number 1, what I will do, interface range E0/0 and E0/1. Before configuring EtherChannel, you should shut down the interfaces. And guys, in last class, as I told you, there is some requirement of EtherChannel. Like requirement of EtherChannel is like speed should be same. Speed should be same of both link. Speed of both links should be same. Then as I told you, duplex should be same. Then all ports should be access port or trunk port. Should be access or trunk. Then trunk encapsulation protocol. Should be getting noise. Should be same. Then allowed VLAN on the list, on the trunk link. Allowed VLAN should be same, right? Then native VLAN should be same. Right? So these are requirement of EtherChannel. Okay. So by default, SP, duplex, encapsulation protocol, trunking, allowed VLAN and native VLAN are same on both interface, on 0/0 and 0/1. So we can form EtherChannel here, right? But before configuring EtherChannel, you should shut down the port. This is just a recommendation, right? You can avoid it also, but sometime you will face some issue if you will not shut down the port and you will configure EtherChannel. So that's why it's a recommendation that whenever we are configuring EtherChannel, first we should shut down the port, and then after EtherChannel configuration, you should run no shut command. Okay, so let me shut down the port, and then we can say channel group, right? This is command channel group. Then we can use a group number from this range 1 to 255. So let me use group number 1 here, group number 1, and then mode. Right? So in a static method, mode will be on, and if you will put question mark here, you can see how many modes we have, right? On is there. On mode means we are configuring EtherChannel manually, both sides. We are not using any protocol. And active and passive, these two modes are for LACP protocol, and desirable and auto, these two modes are for PAGP protocol. So if I will set mode auto over here, automatically PAGP protocol will enable. If I will set mode active over here, automatically LACP protocol will enable over here, right? If I will put mode on over here, right? So this is static method. Then both sides you have to configure on mode. Fine. And guys, in PAGP we have two modes. First one is auto and second one is desirable. So desirable mode is exactly like dynamic desirable in DTP, right? It will always initiate the ether channel. It will always initiate the bundling, and auto will always wait, right? Let's say on switch number 1, if I will configure desirable, and on switch number 2, if I will configure auto, right? It can form ether channel, right? But if both side mode is auto, then ether channel will not come up, because auto is exactly like dynamic auto in DTP protocol. It will always wait for negotiation. In the same way, in LACP we have two mode. First one is active and second one is passive. Again, active is same like desirable, right? It can initiate the negotiation, and passive can only wait, right? Passive cannot initiate the negotiation. So in PAGP protocol, if I will configure what auto mode, one side auto and another side also auto, will ether channel come up? No, right? One side mode is desirable and another side mode is auto. Will ether channel come up? Yes, right? Both side mode is desirable and desirable. Will ether channel come up? Yes, right? Fine. In the same way, in LACP, active and active can form ether channel. Yes. Active and passive can form ether channel. Yes. Passive and passive can form ether channel. No. Done. So here in my scenario I am going to use mode on now, right? So you can see creating a port channel interface, and name of port channel interface is port channel 1, right? Now here if I will run command, so interface status, let's say, so we have one port channel as well. You can see port channel 1. Fine. So this port is down now, right? So this port is, you can see, unassigned, right, for VLAN, and this port is not connected with any device, so not connect. So interface port channel 1, we can say, right, to check detailed information about this port. So MTU, you can see 1500 byte. This is bandwidth of this physical this logical interface, right? Status is down, line protocol is also down. Right, and second command, show ether channel summary. So ether channel summary. So with the help of this command also, we can say we have one group number 1, name of port channel is PO1, and how many interfaces are there in this port channel? 2, 0/0 and 0/1, 0/0 and 0/1. Now I can run no set command on these interfaces. Interface range is 0/0 and E0/1. Say no set here. Right, now so IP interface brief, I can run this command also. You can see this port channel is up now. Line protocol is also up. Status is also up. Earlier this port channel was down. Here you can see SD. D is indicating what? Down. S is indicating what? It is a layer 2 ether channel, right? So we can form layer 2 ether channel as well and layer 3 ether channel as well, right? Right now we are talking about layer 2 ether channel, right? So earlier this port channel was down, but now if you will run command show ether channel summary, so you can see now your port channel is up, U indicating up, right? In the same way on switch number 2, and here if you will run show spanning tree protocol now, so you can see now spanning tree protocol is running on which interface? This interface. Now I am going to down these two interface, right? So now you can see so spanning tree. So spanning tree protocol is working on this interface now, right? Not working on these physical interfaces. Fine. In the same way, on switch number 2 also, I'm going to bundle these two interface range E0/0 and E0/1, channel group number 1, group number, I can use 10 also, and then say mode, what, on. So EtherChannel summary. So this port is also up, and these are two interfaces in this port channel, right? And here also show a spanning tree protocol. So a spanning tree protocol is working on port channel now. A spanning tree protocol is not working on these interfaces 0/0 and 0/1. Interface range E0/2, E0/3, E0/1/02, 3. I'm going to shut these interfaces, shut down. So a spanning tree. Now a spanning tree is working on port channel only, right? So now we have only one logical link between switch 1 and switch 2, right? And a spanning tree protocol is working on that port channel, that virtual link. So again, on switch number 2, I'm going to up only this interface E0/1 interface 0/1 say no set, and on switch number 1 LAN interfaces interface E0/2 say no set, right? So EtherChannel summary, right? And so EtherChannel, like we can check detailed information, we can check port, we can check protocol. So protocol mode is what, on. That means it is a static method, right? In dynamic method, here you will see mode can be on, mode can be active, mode can be passive, mode can be desirable, or mode can be auto. Here we are not using any protocol here right now. So this is a static EtherChannel configuration. On a particular interface, also we can check, so EtherChannel, and then we can say which command. Let's say detail. So it will show you, detailed information on each port, like on E0/0, what is mode. So this, let's say you need to troubleshoot. My EtherChannel is not coming up, so you will troubleshoot, like on both ports we are running same mode or not, right? So on E0/0, see, you can see mode is on, right? You can check here also on 0/1 also mode is what, on. Then you can check group number should be same, right, on both interface. So you can see group number is also same. But like in this scenario, let's say we have two more link between switch 1 and switch 2. We have two more link between switch 1 and switch 2, and I have bundled these two interfaces in different port channel. This is in P2, and these two ports are bundled in P1, right? So again, a spanning tree protocol will work on these two logical interface, and a spanning tree protocol will block one logical interface, maybe this interface or upper interface. So if you have multiple port channel between switches, a spanning tree protocol will allow only one port channel. Otherwise, again, loop will form. Why? Because in last class, what I told you, that whenever switch will receive broadcast message, right, it will check I am receiving broadcast frame on the interface which is member of which port channel. So I will not forward this broadcast message from any interface which are member of same port channel, but switch 2 can forward it from another port channel interface. So again, loop will form here, right? So if we have multiple port channel between switches, again a spanning tree protocol will work same like on physical interface. It will block one logical link.
Maximum how much interfaces we can bundle?
In a static, you can bundle up to 8 link. In PAGP also you can bundle up to 8 link. In LACP you can bundle up to 16 link, right? But again, only 8 links will be in active state and 8 link will be in standby state. So when any active link will goes down, then standby link will come in active state. So at the same time, max to max 8 link can be in forwarding state in all method also, in PAGP also, and in LACP also. We have some verification command, so EtherChannel, and then we can use these all command, like we can use port channel number, we can use load balance command over here to check which load balancing algorithm is running. So which load balancing algorithm is running by default? Source and destination IP address, means on the basis of source and destination IP address, this switch will perform load balancing.
How it will do? Can you please explain this source and destination?
Load balancing.
Yes, yes.
Okay, wait. I will. Protocol. Then we have summary command. Generally, we are using this command, right, for troubleshooting. EtherChannel summary. Okay. Now, first of all, let me configure any protocol here. Interface range E0/0 and E0/1. I'm going to remove this command no channel group 1 mode on, right? I will run this command on switch number 2 also. Interface range E0/0 and E0/1. Do so. EtherChannel summary. Right. Now, how to configure protocol? See, to configure protocol also, just you need to change mode. Interface range E0/0 and E0/1. Here we can say channel, group, mode. If I will say desirable, channel group number 1, mode, let's say desirable. That means we are running which protocol here? PAGP. And so EtherChannel summary. Here we are able to see protocol. No. Protocol is PAGP. And which mode I have configured here? So for that, what command I can run? So EtherChannel detail. It will show me port on all interfaces. Right? Protocol is PAGP. On switch number 2, I can configure either desirable or auto. Interface range E0/0 and E0/1. Channel, group, mode, auto. Right? So it will take some time. Soon it will come in. This port channel will come up. Fine. Okay, in LACP, if I can bundle 16 link. Let's say I have two switch 1 here and switch 2. Most of the time, guys, interview will also ask you question from LACP protocol only, right? Like how switches is going to, decide which port will be in active state, which port will be in standby state. So let's say here we have 16 link. 1, 2, 3, 4. In LACP only, we can bundle 16 link. So and 8 link will be in forwarding state. So try to understand which 8 link will be in forwarding state. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. So let's say this is 0/1 interface. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So port, see in LACP, actually there are port role. Port will have, LACP port ID. Like in a span tree, we have what? Port priority for each port. In the same way, in LACP, we have LACP port ID. Right? Each port will have one LACP port ID. And LACP port ID is nothing but combination of, again, two things. LACP port ID. It is combination of, first thing is priority, and second one is interface ID. Interface ID. And by default, priority is 32768. 32768. Right? So what will be LACP port ID of this interface? 32768 plus 1. right? So it will represent like this: dot 1, dot 2, dot 3. And first 8 port who will have lower LACP port ID, those port will be in active state, and rest 8 ports link will be in standby state. Getting my point? So these 8 ports will be in active state, and these 8 ports will be in standby state. Now again we have one problem. Let's say here on switch number 2, this is my link number 15. This is 15, this is 14, 13, 12, 11.
16 or 15?
Sorry. 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now on switch number 1, these ports should become active, and on port switch number 2, these ports should become active because these ports have lower LACP port ID. Yes or no?
Yes.
So now here let's say we have one user, and here also we have one user. Can these users communicate with each other? Can these users communicate with each other? No. So first of all, when you will enable LACP protocol, once you will enable LACP protocol, one switch will become main switch. One switch will become main switch. Switch who is going to decide which port will be in forwarding state and which port will be in blocking state, right? Like in a span grid protocol, we have root bridge. Like that in LACP, one switch is going to become master switch. Now again, question is which switch will become master switch? Which switch will become master switch or main switch? Right? So for that, guys, in LACP we have a term called system ID. System ID. Switch who will have lower system ID, that switch will become master switch. And system ID is again combination of two things: priority plus base MAC address. Base MAC address. Okay. Again, priority is by default 32768. So let's say switch 1 MAC address is 0A and switch 2 MAC address is 0B. So system ID of switch 1 is 32768 plus 0A, and system ID of switch 2 is 32768 plus 0B. Now which switch have lower system ID? Switch 1. So switch 1 is my main switch, or you can say master switch. Right? Now switch 1 will decide which port will be in forwarding state and which port will be in active state and which port will be in standby state. So according to switch 1, these 8 ports should be what? In active state. So according to that, switch 2 is also going to put these all interfaces in active state and these 8 interfaces in standby state. Is it clear?
Can we increase the priority? Lower priority will be preferred, right?
Right.
So can we decrease the priority?
Yes, of course.
And
like in a spanning tree, we can increase or decrease priority. Here also you can increase or decrease priority. Let's say you want switch 2 should be my main switch. So here you can configure priority 0.
Okay.
Fine. Now, Vasavaraj asked how load balancing is going to work, right? So see, if let's say in this scenario, switch 1 is connected with one router and this router is connected with ISP. Just I'm creating scenario, okay? Because of that I'm connecting one router here and one ISP over here. R1. Guys, on real devices, you will see by default load balancing algorithm is source MAC address. Means switches will perform load balancing on the basis of MAC address, source MAC address, only on the basis of source MAC address. on real devices. If I will access my switch in rack, just give me 1 minute. Yes, I have turned on the rack. Just wait for some time. On real devices, you will see by default load balancing algorithm is source MAC address, means which will perform load balancing on the basis of source MAC address. So in this scenario, 8 links are in active state. These 8 links are in active state. So let's say here I have one user. Here I have one user on switch number 2. Right? This user MAC address is, just suppose, A. Right? And this interface MAC address is, let's say, C, default gateway. This will be default gateway for all the users. So whenever this user will ping, let's say 8.8.8, source MAC will be what? A, and destination MAC will be what? C. Destination MAC will be C. When, let's say here we have one more user. This PC MAC address is B. Right? So when computer A want to communicate with internet or outside user, source MAC will be A, destination MAC will be C. On the basis of source MAC address, switch 2 will perform load balancing, right? Let's say switch 2 have, use this link to forward traffic. For computer B, it will again perform load balancing on the basis of source MAC. It will check source MAC is B. Let's say it have used this link to forward traffic or computer B. But for reply, when reply will come up, right, from ISP, every time source MAC will be C and destination MAC will be A, or C, destination MAC will be B. For all user, let's say here we have thousands of user or 100 number of user. For all 100 number of user, destination source MAC will be always what? C in the reply packet. So can switch 1 perform load balancing? No. Switch 1 will use only single link, because by default, if it is performing load balancing on the basis of source MAC, so every time source MAC will be C in the reply packet. Definitely switches will perform load balancing for the traffic which users are generating, right? The traffic which is moving from user towards ISP, but for the reply packet, it will use only single link. Yes or no? So we need to change load balancing algorithm in this scenario. So we have multiple types of load balancing algorithm, right? In EVNG, we are not able to see multiple load balancing algorithm, right? Here, if I will run this command, interface range E0/0 and E0/1, save channel group number 1, and then mode, let's say auto. Here, not here. You will run this command in, I think, global config mode. Port, channel, then load balance, and put question mark. You can see how many load balancing algorithm we have. Destination, on the basis of destination IP address also we can perform load balancing. On the basis of destination MAC address also we can perform load balancing. On the basis of source and destination IP also we can perform load balancing. On the basis of source and destination MAC also we can perform load balancing. On the basis of source IP also we can perform load balancing. And on the basis of source MAC also we can perform load balancing. And this is default. This is default. By default, switch MAC, running source MAC address algorithm for load balancing, right? And guys, if we have, let's say, 8 link, so to represent 8 link in binary, if you need to represent 8 link in binary, right, how many bits is required? How many bits is required to represent 8 link? 3 bits? Can I represent 8 link with the help of 2 bits?
No.
No. 2 bits can be 0, 1, 0, 0, 1, 0, or it can be 1, 1. So we can represent only 4 link with the help of 2 bits. So I need how many bits? 3 bits. So if load balancing algorithm is source MAC address, when switch 2 will receive frame, it will convert source MAC address into binary, and it is going to use last 3 bits. So if I will convert A into binary, what will be binary of A? 1010. So it is going to use last 3 bits. Now it will convert these 3 bits into decimal value. So what will be the decimal value? 2. That means switch is going to use link number 3. Switch is going to use link number 3. It will forward traffic from this link. In the same way, for this computer, load balancing algorithm is source MAC. It will convert source MAC address into binary. What will be binary of B? 1011. It will use last 3 bits, it will convert it into decimal, it will get value 3, so it will use link number what? 4. It will use link number 4. This is how it is going to perform load balancing. EtherChannel is going to perform load balancing. Clear? If we have only 2 link, let's say in this scenario, so to represent 2 link, how many bits is required? Only one bits is required, yes?
0 or 1.
0 or 1. So if we have only 2 link in the port channel, and let's say PC1 MAC address is A, right? When PC will forward the frame to switch will convert A MAC address into binary. So again, binary of A is 1010. It will use last bit. What is decimal value of 0? 0. It will use link number what? 1. 0 plus 1. It will add 1. Right? So let's say LACP port ID of this interface is 363 priority plus interface ID. Let's say 1, and LACP port ID of this interface is 2. Right? So it will use this link. For another computer whose MAC address is B, again it will convert it into binary 1 1. It will use last bit. Decimal value of this value, this binary is 1. So it will use link number what? 2. It will forward traffic from upper link. Right? So last bit's value can be what? Either 0 or can be either 1. So if we have only 2 link, so LACP will perform load balancing on 2 link. If last bit is 0, it will use link number what? 1. If last bit is 1, it will use link number what? 2. Clear? This is how it will perform load balancing. Clear, Vasavaraj?
Yes.
Okay. And have you understood what is problem with source MAC address?
Yeah, if suppose many users are there, means that time how it will take?
Yes. Let's say we have 100 number of users. Same thing will happen for all users. It will convert source MAC address into binary, right? If there are 8 link, it is going to use last 3 bits. Then it will convert that last 3 bits into decimal value, and it will add 1. And on real device, let me check I am able to access real device or not. Secure CRT. Yes. Which algorithm is running by default? Source MAC.
Source MAC address.
Yes. If you will change load balancing algorithm, yes. In another load balancing algorithm, let's say if I have set load balancing algorithm source and destination, then what switch will do? Switch 2, switch 1. We have, let's say, only 2 link. Okay, here I have one user whose MAC address is A. Here I have one user whose MAC address is, let's say, B. So if this user will generate traffic, source MAC will be A, destination MAC will be B. Here algorithm, load balancing algorithm which is running is source and destination. Now this time this switch will convert source MAC address also and destination MAC address also into binary. So binary of A is 1010, binary of B is 1011. Now it will use last bit, so it will perform here AND operation. It will perform here AND operation. And after AND operation, 01 will be what? 0. So it is going to use link number 1. Same thing will happen in case of source IP. Source IP, right? It will convert source IP address into binary. It will use last bit. Same thing will happen in source IP and destination IP. Right? It will convert both source IP and destination IP into binary. Let's say this machine IP address is 10.1, this machine IP address is 10.2. It will convert 1 into binary. So binary of 1 is 1, binary of 2 is, right? So it will perform AND operation over here. It will again going to use which link? Link number 1, like this. So in all load balancing algorithm, right, switches is going to forward traffic from the physical link only, right? If we have 8 links, switches will use last 3 bits. If we have 4 links, switches will use last 2 bits. If we have only 2 bits, switches will use 1 bit.
To select which link among
Yes,
the port channel links.
Correct. We have 8 link between switch 1 and switch 2. Then load balancing algorithm will be like this: 1 ratio, 1 ratio, 1 ratio, 1 ratio, 1 ratio, 1 ratio, 1, 2, 3, 4, 5, 6, 7, 8. If one link will goes down, now we have how many link between switch 1 and switch 2? 7 only. So if we have only 7 link, then load balancing algorithm will be like this: 2 ratio 1 ratio 1 ratio 1 5 6 7. If we have only 6 link, then my load balancing algorithm will ratio will be like this: 2 ratio 2 ratio 1 ratio 1 2 2 4 5 6, like this, right? Means it will forward 2 packet from link number 1, it will forward one packet from link number 2, 1 packet from link 3 4 5 6 7. 1 minute guys. Yes. So if we have 4 links, switch will check last 2 bits. And to change load balancing algorithm, simply you need to run this command: channel port channel, then load balance, and after that algorithm. So on real devices, you can see we have destination IP address algorithm, destination MAC address algorithm, source and destination IP address algorithm, source and destination MAC address algorithm, source IP and source MAC. So by default, the algorithm which is running is source MAC, right? But in source MAC, as I told you here, what is problem? For return traffic, switch 1 will not perform load balancing, right? So either here we can use what? Source and destination MAC address. So again, if we will use source and destination MAC address, so every time source MAC address will be C, right, in the reply packet. So which type of algorithm we should use? Here I can use source IP and destination IP. Here I can use source IP and destination IP, so that both switches will perform load balancing on the basis of source IP and destination IP, right? So source IP will be 10.1, destination IP will be 8.8.8. It will convert both into binary, then it will use last 3 bits. Now guys, I have, let's say, one scenario here: switch 1 and switch 2. These are multi-layer switch. These are multi-layer switches. Here I have one computer. Okay, let's say one computer only. One computer is here, one computer is here. This PC, this is like real-time scenario. So this is PC1, PC2. Okay, switch 1, switch 2, and this user is in VLAN 10. This user is VLAN 10, and this user is in VLAN, let's say, 20. IP address of PC1 is 10.1.1.1. IP address of PC2 is 20.1.1.1. Fine. So here, to make communication between VLAN 10 and 20, you have to create SVI on multi-layer switch. So here you will run one IP address on interface VLAN 10. Let's say IP address is 10.1.1.100/24. Right. On switch number 2, I have one SVI VLAN 20, interface VLAN 20. And on this interface, my IP address is, let's say, 20.1.1.100. So in this scenario, let's say in this scenario, how 10.1 can communicate with 20.1? I need to connect one link over here, and you will configure this link as trunk. Now can PC1 ping to PC2? No, because in the routing table of switch 1, we will have only 10 network. In the routing table of switch 2, we will have only 20 network. Yes or no? So to make communication here, what we need to do, either I can configure a static route between switch 1 and switch 2, or I can configure dynamic route, or I can configure dynamic protocol. So to run a static route or dynamic route, you have to configure IP address on this interface, right? Let's say here I have configured IP 12.1.1.1, and here I have configured IP what? 12.1.1.2. Now I can configure a static route, or I can configure dynamic route. Yes or no? On switch number 1, I can run command IP route. 20.1.1.1. Next hop IP address for this network is 12.2. Right? In the same way on switch number 2, I can run one route, IP route, and 10.1.1.0/24. Next hop is 12.1.1.1. Now can PC1 ping to PC2 now? Can PC1 ping to PC2? Yes, it can. It can ping. Ping will work here. But what problem we have? Let's say in a static route, if we have multiple, multiple user are in multiple VLAN on switch number 1 also and on switch number 2 also, then you need to create lots of static entry. So again, that is complicated. So what you can do, you can configure one dynamic routing protocol here, EIGRP. Let's say I have configured EIGRP here. Now what will happen? EIGRP neighborship will come up between switch 1 and switch 2, right? And through EIGRP, we can exchange 10 network and 20 network with each other. But if link between switch 1 and switch 2 will goes down, EIGRP neighborship will goes down. So what I can do, I can connect one more link here. And on this link also, I will configure one IP address. Let's say here IP address is 21.1.1.1 and here 21.1.1.2. So now we will have 2 EIGRP neighborship. If we will connect one more link, we will have 3 number of EIGRP neighborship. So after every 10 seconds, both switch will generate 3 number of hello messages, and it will receive also 3 number of hello messages. So CPU utilization of devices will increase automatically if we will have 3 number of neighborship between switch 1 and switch 2. And if we will have more than 3, let's say 5 neighborship are there, we have 5 link. So to reduce these type of problem, we come up with layer 3 ether channel. Layer 3 ether channel. Till now, whatever things we have discussed, that is layer 2 ether channel. Right? In layer 3 ether channel, what you can do, you have multiple link between switch 1 and switch 2. Now you can bundle these link, right? And then on your port channel, right, on your virtual port, let's say P1 and here P2, on this port channel you can configure IP address. Let's say here my IP address is 192.168.1.1. Here my IP address is 192.168.1.2. Now through this logical interface we can form EIGR. So if one link will goes down, right, still we will not have any problem, because still we have 2 links between switch 1 and switch 2. Clear? Any question guys in ether channel? This is all about ether channel. We can perform lab of this scenario also, or you can perform this lab by yourself also, because it is very easy. Here?
You do it, sir.
Okay.
G, recording is on, right?
Right.
Okay.
Channel, group, number 1, mode. For LACP, mode is active. Channel, group, 1, mode, we can say passive. And so ether channel.
That group number we should use that same, right, at that both switches?
No, we can use different also. It is locally significant.
Okay.
Protocol is LACP. Now in this scenario, I'm going to remove LACP configuration. And this time, what I will do, interface is 0/2, switch port access VLAN 10. I have put this computer in VLAN 10. On switch number 2, do so ether channel summary. Interface is 0/1/0, switch port access VLAN 20. Interface Now here we can configure IP address on port channel 5. Now ping is working between switch 1 and switch 2. Now what we can do here, I can create one SVI interface VLAN 10 IP address 10.1.1.1 255.255.255.0 and say no set also, and do so IP route. In the routing table we have 12 network and 10 network on switch number 1. On switch number 2 interface VLAN 20 IP address 20.1.1.1 20.1.1.1 255.255.255.0. right. Now router EIGRP is number 10 and network 12.1.1.0 on switch number 1 also. Router EIGRP is number 10 and we can say network 12.1.1.0. okay, so we have EIGRP neighborship, so IP EIGRP neighbor neighbor, okay, Q count is 0. You can see we have only one neighborship, but how many physical links are there between switch 1 and switch 2? 2. So if one link will goes down also, right, we will have EIGRP neighborship. So in the same way, let's say we have multiple link, 5 links, 6 links, right, we can bundle those all link into L3 ether channel, and then we can form, you know, a dynamic routing protocol neighborship also, and after that we can exchange prefixes also. On router, on switch number 1 router EIGRP, then I can run network 10.1.1.0, and here router EIGRP.
Yes, sir. This was my question.
This was your question.
Yeah, this was my question. Here, when you do the IP neighbor, you see the other router via the port channel. But when you do CDP, you're not seeing the other router or switch via port channel. That's my question.
No,
Why?
so CDP you will see only, you know, devices connected on physical interface.
Okay, okay.
Is it CDP?
CDP by default CDP is enabled on all switches, on all Cisco switches. It is again Cisco proprietary protocol. It is used to check layer 2 information, right? Directly connected devices. Like on switch, if I want to find how many devices are connected on, or which devices are connected on which interfaces, we can use CDP protocol. But nowadays we are not using it. We have actually two protocols, CDP and LLDP. CDP is Cisco proprietary, LLDP is open standard. But CDP is not secure, LDDP is also not secure. Both are unsecure protocol. So if anyone will connect their device, they will get CDP message. They can, you know, get basic information about device. So CDP so you can see CDP messages, hello message of CDP, sending CDP packet every 60 seconds, and hold on time is 80 seconds. Means after 60 seconds, it is sending one CDP message from their each interface, from their all interface. Debug CDP events. Okay, so it have received one CDP packet on 0/1 interface from switch number 2. Right, so it will make one entry in their CDP table. A device whose name is switch 2 is connected on this interface.
Actually, what you said about that LLDP, what is the use of LLDP?
Same use.
To check that layer 2 connectivity?
Connected device.
Connected device?
Yes. So EtherChannel is over. Now we have next string protocol, that is.
So one more.
Yes, go ahead.
One more question on EtherChannel. on the switch 1, the both physical interfaces 0, 1 and 0, 0. Is it possible to bundle fast Ethernet and Giga Ethernet?
No. Ethernet, again, Ethernet standard is
Because
different.
they have to be the same speed. But, okay.
Same speed, and even if you will configure, you can configure a speed manually as well. You can change it. Even you will change the speed. If you will configure same speed, then also EtherChannel will not come up because of Ethernet standard. Right? Ethernet standard will be different for gig link and for fast Ethernet link. So Ethernet standard should also be same.
Okay.
Sir, can you give this command? Show LACP sys ID.
So
Show LACP sys ID.
LACP
Sys ID.
system ID.
Yes.
Yes.
This is the base MAC of which one?
Correct.
And priority.
LACP port ID activation by lowest port priority of EtherChannel by default. This one, okay, lowest port number priority plus interface number. Active interface, those have lowest LACP port ID. Same thing. Switch election LACP system ID, okay. For 2 link, it is going to use 1 bits. For 4 links, it is going to use, okay. 2 links, at least 1 bit side is okay. So you can see how it is performing load balancing. It will convert it into binary and then decimal. For hexadecimal value 0. Binary interface is 1.
So have you shared this document to us?
Yes. You have it. In group
Okay.
also you can check. Recently I have shared it in group.
Okay.
Interface range F1/0/1. Sorry, 1 not 21 to 22. Here what command I can run for to change the ID? In global config mode you can change priority, right? And on interface you can change port priority. So here I can say LACP port priority. So LACP internal port priority is now 10. Interface range F1/0/21 to 22. LACP port priority. Only we have option of port priority here. LACP system priority. We can change only system priority over here. So we have only these two commands.